All right. I probably have time for one more. Ooh, this might be tough. Validate binary search tree. All right, let's give it a try. Given the root of a binary tree, determine if it is a valid binary search tree. Left subtree of node contains only nodes with keys less than the node's key. Right subtree of node contains only keys with greater than the node's key. Both the left and right subtrees must also be binary search trees. All right. Yeah. Okay. This might be... I don't know if I can solve this in the time I have left. Let's find out. But it's clearly we got to do some sort of recursive solution, right? Because that's the way trees work. 0098 validate binary search tree. All right, we'll grab this, copy, and oops. Paste. There we go. I do have to pull in my tree node code. If I try to build it, it should tell me. Oh, wow. I thought it would give me the library. Oh, right. Pub struct solution. Let's actually move that up here because I don't want it to be part of the bit that I do. Okay, so now it should give me tree node. Yeah, there we go. Import create tree node. There we go. And this just return false for now to get it to build. And then we're done. Okay, good. Let's switch this over to the test. And now let's add these two examples as our tests. All right, so example 1 here. I've kind of forgotten how test mod. Yeah. Oops. Test. EX1. We're expecting true from solution is valid BST tree node new, and I think I can just give it the vec 213. Yeah, and that we have 2 errors. Oh, it's an option RC ref. Oh, I thought that's what that returned. Let's find out. Or do I have a, yeah, it's a from vec, which returns the option RC ref cell. Okay. So let's change that from vec. There we go. Okay, and then the other one is not a valid one, right? That's a false. And then we have to change the nulls to I32 max. Okay. X2, assert, and this is just solution. Oh, not solution. Is valid BST, tree node, from vec, paste. And change the nulls to I32 max. I'd love to know how they have their tree node implementation. It would be nice if they exposed that, because then we could just use it. All right. So we have one error. Oh, it's from vec. Duh. Semper Sleep. Thank you for the follow. Thank you very much. Much appreciated. Welcome. Okay, so we have a possible solution. It would be to walk the left to make sure all the values are less than our current node. Because tree node, let's take a look at tree node real quick here. Oh, it's right here. Yeah, it's just an I32 val, and it's got a left and a right. So we can walk the left to make sure everything to the left of us is less than our current val, and everything to the right of us is greater than our current val, and then we have to call is valid BST on the left and on the right. So maybe we can do this recursively right in here. Let's find out if we can just do this. If root is none, return true. Right, and then what we can do is we can say self is less than, or is less root. Oh, I guess what we can do is here is if some node is equal to root, and then this be else return true. So now we have the node. If less node dot left, comma root dot val, node dot val, and self is greater node dot right, root dot val, node dot val, and is self is valid BST node dot left, and self is valid BST node dot right. And then we just have to write the is greater and is less, and we can just stub those out for now. Let me just copy paste. Returns bool. Let's just say false, and then is greater. Oops! Wow, I can't type. And we do need to have the val in here. Right. So let's do that. Does that build? It does not build. If let some. Isn't node a tree node? Oh, RC ref cell tree node. Right, node borrow. Doesn't like that. Move occurs because, oh, do we have to give it? Oh, yeah, if we do that, and then we can't call this thing here. Okay. Okay, so we're going to do this. Boom. And boom. And we're going to just have this, and this is going to be fun validate tree root, which is this bool. Right, and now we can pass that in. Validate tree root. Self. Slef. I think slef should be an alias. Oh, right. I have to change this to validate tree. Okay. We have a failure, which we're expecting because we don't have any of this stuff. And then we have all of this stuff, which we're going to fix now. Okay. We're almost there. Is less. So we're going to say if every node in this tree is less than val. Node dot if let some node is equal to node, else true. If there's no nodes left, then everything is less than. Then it's going to be val is greater than node.borrow.val, and self is less node.borrow.left, and self is less node.borrow.right. Right? We need to make sure everything in this side of the tree is less than this value. Oh, and then we have to pass this val in. Right? And we do the same thing for greater. Oh, these are not functions. Yeah, and now we just do the same thing here. And instead of calling it as less, we want to call it greater. And we want to make sure that val is less than node borrow val. All right. That passes those tests. Is there anything else that I'm missing here? Number of nodes in the tree range is 10 to the 4. And any value can be... Okay, so basically I32 min to I32 max. Yeah, and I don't think we have any restrictions on that. So I think, yeah, I think this might be the solution then. Let's move this use crate thing up here at the top because I don't want to copy paste that. We do want to copy paste standard cell, ref cell, all the way down to here. Paste. Yeah, that looks right. Let's see what happens. Look at that. It's accepted. It's slow, but it works. Okay, now I'm curious what the fast one was. What are we at anyway? Okay, 6 milliseconds versus 0 milliseconds. That might be in the noise. Oh, so they put their function directly inside. Okay. Yeah. And that way you don't have to do all that self : business. Maybe I'll have to use that trick in the future. All right. I think we're good. Let's see here. I'll return true. Where did I put return true? I've just lost all my Rust cred. Return true. Pff. Be nice to, if there was some shortcut for this. Like this could return none. Yeah. I'm thinking, well, we could use the question mark operator and have this be an option bool. Yeah. If we made these option bools, and then this could return, right? Because then I could just say question mark. Let some node equals root question mark. Would that clean it up at all? Or would that just make this... This would make this a little more awkward because we have to say if let some x result equals this result else true. That's awkward, but this is why the reason I'm thinking of that is I could just make these option pools, and I could just say let node equals root, and then just return that, and this will end up returning none. Oh, it doesn't this. Oh, because it's a ref like this. You can't do that. Yeah, that's a shame. So it has to be a straight up option. I would have to make it this, right? And that would change everything. Yeah, and I can't pass in that ref. I'd have to unwrap it here. Nope. Like that. Yeah. And then these guys would have to get the same treatment. Right. I don't know if this is rustier or and harder to read, or let node equals root. Oh, node. let node equals node. These technically should be called root because it could be any part of the tree, right? I said I was out of time. I got to stop. Let's see what this does. Oh, right. So now load borrow left as ref. I have to put as ref everywhere. And then put the question marks. So I think this is worse, right? Oops. That blew up completely. Undo there. Oh yeah. Now question marks here. No, okay. I'm done. I thought it would be neater to try to use the option thing for make it feel a little more rusty, but it's making it actually worse. Okay. I'll have to think about that, and maybe there's another approach we can use to make it rustier. All right, git status, git add source, git commit -m, problem 98, validate binary search tree. All right, and I'm going to push this up. We'll take a look at our commits. Oh, wow. Refreshed it already. Okay. And then the next stream, oh, we get to check this one off. Next stream, we'll do number of islands and rotting oranges, and then we'll keep going. Search in rotated sort array. That sounds interesting. Combination sum, permutations. Okay. We actually can probably steal some of the code we wrote for additive code to do this. Merge intervals. We did insert interval earlier. Was that in week 3? Yeah, there's insert interval. So this one is merge intervals. So that's going to be fun. Lowest common ancestor of a binary tree. Time-based key value store. Counts merge and sort colors. That's week 5. Okay, we haven't even finished week 4 yet. Yeah, the next stream we'll start with number of islands and see where we can go from there.